Hello, welcome to another math class session. For today's video, we will be dealing on operations on functions and composite of functions. At the end of this video, you are expected to add, subtract, multiply, and divide functions and solve composite functions. Before we start, let's have an overview of this lesson. So this lesson requires skills such as performing arithmetic operations on algebraic expressions. So the most important concept you need to understand in this lesson is if we combine two or more functions, we produce a new function. Now to start, let f and g be functions. So in operations on functions, the operation involved are addition, subtraction, multiplication, and division. If we get the result of this operation, we get sum, difference, product, and quotient. Now to get the sum of two functions, function f and function g, we have f plus g of x equals to f of x plus g of x. Now to get the difference of two functions, function f and g, we have f minus g of x equals to f of x minus g of x. For product, we have f times g of x equals to f of x times g of x. For quotient, we have f over g of x equals to f of x over g of x. Another way of combining function is so-called function composition, defined by this notation. So this notation can be read as function f composed with g or f circle g. So the small circle inside the parentheses with function f and g is used as an operator like bullets for performing multiplication. In solving problems involving composition of function, the second function is always inserted to the first function. In this form, function g is inserted to function f. To fully understand the concept of operations on functions, let's have an example. Given we have f of x is equal to 2x plus 1, g of x is equal to x squared minus 2x plus 2, and h of x is equal to x minus 1 over x plus 2. So the problem is perform the following operations. So for number 1, we have f plus g of x. Number 2, f minus g of x. For number 3, f times g of x, or f all over h of x. Number 5, h composed with f of x. To solve problem number 1, we will just apply getting the sum of two functions defined by f plus g of x is equal to f of x plus g of x. We know that the value of f of x is 2x plus 1 and the value of g of x is x squared minus 2x plus 2. So we will just apply direct substitution. So we have 2x plus 1 plus x squared minus 2x plus 2. To get the sum of function f and g, we will simplify this one by combining like terms. So we have x squared. So 2x minus 2x, that is 0. So no need to write 0. Then 1 plus 2, that is 3. So the sum of function f plus g of x is equal to x squared plus 3. For problem number 2, we have f minus g of x is equal to f of x minus g of x. So apply direct substitution. We have 2x plus 1 minus x squared minus 2x plus 2. Then we will just distribute negative sign to each term inside the parentheses. So copy 2x plus 1. Then negative times x squared, we have negative x squared. Negative times negative 2x, we have positive 2x. Negative times positive 2, we have negative 2. And then simplify by combining like terms. We have x squared So 2x plus 2x, that is 4x. 1 minus 2, that is negative 1. Therefore, we have negative x squared plus 4x minus 1. For problem number 3, given that we have f times g of x is equal to f of x times g of x, substitute the value of f of x and g of x, so we have 2x plus 1 times x squared minus 2x plus 2. To multiply 2x plus 1 to x squared minus 2x plus 2, we will follow FOIL method. So FOIL method stands for first, outside, inside, and last. So we will just apply the FOIL method. So we have first, outside, inside, and last. So we have 2x cubed, 2x times negative 2x, we have negative 4x squared. And then 2x times 2, we have 4x. So 1 times x squared, we have x squared. 1 times negative 2x, we have negative 2x. 1 times 2, we have positive 2. Then, by combining like terms, we have 2x cubed. So for negative 4x squared plus x squared, we have 3x squared. 4x minus 2x, we have 2x plus 2. Therefore, the product of function f and function g is 2x cubed minus 3x squared plus 2x plus 2. To solve for problem number 4, we have f all over h of x is equal to f of x all over h of x. So we will just apply the value of f of x and the value of h of x, which is x minus 1 all over x plus. So we have 2x plus 1 all over x minus 1 over x plus 2. Now, to divide 2x plus 1 all over x minus 1 over x plus 2, we will reciprocate x minus 2 all over x plus 2, and then we will change the operation to multiplication. So we have 2x plus 1 times the reciprocal of x minus 1 all over x plus 2, which is x plus 2 over x minus 1. Multiply 2x plus 1 to x plus 2 by applying FOIL method. So first, outside, inside, and last. So we have 2x squared, and then plus 4x. 1 times x, we have x. 1 times 2, we have 2. All over x minus 1. So we have 2x squared plus 5x plus 2 all over x minus 1. So that the answer is 2x squared plus 5x plus 2 all over x minus 1. To solve number 5, we will just apply the function composition defined by h composed with f of x is equal to h of f of x. So we know the value of function h is equal to x minus 1 all over x plus 2. Then, we will just substitute the value of f of x, which is 2x plus 1, in variable x in function h. So we have 2x plus 1 minus 1 all over 2x plus 1 plus 2. So is equal to, and then simplify, we have 2x all over 2x plus 3.